How are you, dear? Today we're going to talk about scalene triangle. Scalene triangle, it's like a scale. It does not have any sides same length. So we're going to start by creating one line, and I would like to make this line to be about 9 centimeters. So I'm going to thick 9 centimeters line. Line segment will be, for example, if I say this is KM segment, and I have point M and point K. A scalene triangle has to have one obtuse angle. So I will choose to have 130 degrees angle from the point K. So I'm going to put my protractor on a point on a K, and I will look where the line, if line is like that, that's not, it's parallel to the line segment KM. So when it's parallel, when it's on a line, that means that is the zero line. So I can go and I can see there is a 10, 0. This is 0. Then you have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. If I go like there, and put my dot right there, not on 130, I will have another point dot on that line segment, and then I can connect and extend if I really like something that it's bigger than this line. So how about if I measure this 6 centimeters? So I can do 6 centimeters. So I'm going to need a little bit more of the line. So I'm going to go a little bit more. And then here is the 6 centimeters that I need. So here is my next point, which I will call point L. When I have these 3 points, I can connect L and M point, and I will have a third line segment of my scalene triangle. Okay. Then I can show you how this is a 130 degrees angle, is obtuse angle. If I take my angle and press my compass very sturdily to the point K, I can do the line, the circle around the K, and all the way around. You'll see that my do it a little more better. Okay, so you can do with 2 fingers, just like going around, and that will be my part, my angle that lives in a circle. Angles lives in a circle, and this is my angle, and then the rest of the circle is a reflective angle, reflex angle called. Okay, so I can label my angle like that, 2 arrows in arc, and I can show you that is, I actually measure it, but I can do one more time if you don't believe me. There is from 0 point all the way to 130 degrees. So sorry, I messed up this one. This one is correct. When you go around, and that is 130 degrees. Remember that all 3 angles in any triangle has to add up to 180 degrees. So these 2 need to share whatever it's left to up to 180. So I can measure angle M, and I can put my dot of my protractor on M, make parallel to the line segment MK, And look, now it's outside the 0. 0 is right here. So I can go 0, 10, and where meets my line ML, you can see that is exactly 20 degrees. So this angle is 20 degrees. So now I can measure the third one, or I can just figure it out by adding up to 180 or subtracting from 180 what I have. So I can see on the side here that I can say, okay, I have 130 degrees and I have 20 degrees. That will be 150 degrees. So I really know that only 30 more 30 more degrees and I will have a 180 degrees. So that is definitely, this is 30 degrees angle. So none of the angles are the same and none of the sides are the same. So all these three angles are different sides. And then the other way is, if I have no than 180 is minus 150, these two, then they will give me 30 as an angle. So we can label this triangle as, so if points are labeled with a capital letter and then sides are labeled with a lowercase letter. So if this is M, that's a line segment M, so that we can say that is equal to 9 centimeters. So I can measure it, and it's like here 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters. 9 centimeters. I can measure line segment K and L, and that is about 6 centimeters. So I can also mark those centimeters if I need to. And I will have a K to be, let's pretend that this is a K. Line segment K, that is equal to 6 centimeters. And then last, I could have L to be, line segment L is going to be about 3, it looks like 13.7, but let's check. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 whole centimeters, and then I have a millimeters. 1, 2, 3, 4, 5, 6, 7 millimeters. So that would be, the L is equals 13 and 7/10. 7/10 or 7 out of 10 pieces that makes a new centimeter. So that would be, so if we want to label, we can label this triangle as a like triangle symbol and KLM. So triangle KLM is a scalene triangle. But when we talk about, when we classify it by sides, so none of the sides are the same, and that's like a scale, and that is scalene triangle. But we also can label this triangle, could be called obtuse triangle. Obtuse triangle. He can get this name because of this obtuse angle. We can label obtuse angle. So scalene triangle can be called also obtuse triangle because it has one of obtuse angles. These two are acute, less than 90 degrees, and this one is more than 90 degrees, and it's called obtuse. We can check that with the the sticker. I like use the sticker, so when we do the checking that is it bigger or less than 90 degrees, I can put parallel my edge of the paper parallel to KM line, and I can see if that angle would be 90 degrees, the angle that this would be the 90 degrees angle. So the line would go straight up from the K, but is much more, it's this much more than 90 degrees, which is 40. So that is really 130 obtuse angle. Another way is to just to dilute the dashes, and you can see that this would be a 90 degrees, but then the rest is a bit greater. So we can label the sides. So we can say KL line segment is just a line on the top, is equal to 6 centimeters. Line segment LM is equals 13 and 7/10 of centimeter. And then line segment MK is equal to 9 centimeters. You can put 9 centimeters. Okay. We can also label angles. Angle K is equals 130 degrees. Angle L is equals to 30 degrees. And then angle M is equals to 20 degrees. 20 degrees. We can explore. Another thing is, especially for sixth grade, is important how to find the height of this triangle. And kids are very often confused how to find the height. We can find a height if we extend the line segment KM, for example. We can extend by dashes. And we go all the way to that we'll have a perpendicular to the point that is opposite to the line that we extend. So we extend line segment K, and then perpendicular to that line segment is the point L, which is the height of the triangle. So we can use our small triangular ruler to help ourselves to make those dashes from L down to the extending line KM line segment, and we can see that this is our height. This line is our height of this triangle. So, and we can measure that h is equals, and if we measure how many centimeters, so it would be, let me just take the other one that's better visible. It's about 4.6 and 6 6 millimeters. So 4.6 centimeters. Okay, so the height can be found by extending the line, find the perpendicular line towards the opposite point, and that would be the height of this triangle. So h is equals 4 and 6 centimeters. Another thing that we can explore is a line of symmetry, and we can also think about if I can cut the triangle to be in the same to get the same equal parts. We really can't do much about this, because if I cut this in half, the pieces will not fit. It will be overlapping this way. And then if I cut other way, okay, that one is also not at all matching, so it's not possible to have a line of symmetry in the scalene triangle. So we can say that scalene triangle has zero line symmetry. And if we try that rotational symmetry, we can find also if this is our shape, and we would like to try that it fits in the same shape. If we rotate, you can see then it does not matches at all. It's always off to the shape until it reaches the same point, which is 360 degrees. So we definitely can say that this scalene triangle has a zero rotational symmetry. Okay. So this will be all for now for a scalene triangle, and thank you for being with me. I appreciate it. I love you guys. Bye from Mrs.Z.